Hello viewers, and welcome to this episode of Bite-Sized Robotics, where we explore the question of how a robot can benefit its owner. Obviously, after specifying exactly what part of humanity you are directing your robot towards, you must answer the question of how this robot is going to benefit them in their day-to-day lives. But first we must explore a concept that I call customer disengagement. Generally, a product is measured against its customer engagement, i.e. it's the time the customer spends actually using it. If you watch a film, you might watch it several times, you might buy its merchandise. This is all customer engagement. The opposite is true when dealing with autonomous systems. A customer buys an autonomous system in order to not have to oversee its operation. Its success is measured against the time that the customer can use elsewhere that would otherwise have to be used on the job that the robot is doing for you. Now, money must be saved by this automation in order to outweigh the setup costs. If the robot ends up costing more than your average guy can do the job for you, then it's not going to function. Also, the robot must integrate into the workplace or the home seamlessly. If the robot's continually getting into the way of the customer's family or the customer's employees, then it's not going to last. The robot must be invisible. That is key. So having gotten that all out of the way, how can the robot actually benefit its user? Well, the most obvious example of this is in the robot's ability to save time. Now let's explore this in two sections: the time that a robot can save for you and the time that you're going to have to actually sink into the robot. In terms of time saved, well, the most obvious example of this is the ability of a robot to do a job while its owner is doing something else. A robot can mow the lawn while you're cooking a meal. This is an obvious benefit because there are only so many hours in a day. Another aspect is the ability for a job to be done faster with the robot helping you. So an example of this might be doing research where some form of expert system can be used to just plod through a load of different examples of a particular aspect of the research while you're imagining something else. Or tangential to that is its ability to refine an enormous amount of information into usable suggestions. You see examples of this everywhere these days. A particular one would be the ability of insurance brokers to refine all the information from its various customers down into models which they can use to then set their prices. Now, where does this backfire? Well, with any complex system, you're going to have to sink time into a very long setup. So, for example, with those insurance brokers, they had to spend an inordinate amount of time making sure that their systems were actually drawing the correct conclusions. And when this doesn't happen, then all sorts of grief can ensue that results in a large amount of litigation. Maintenance is also important. If the robot breaks down and it takes ages for it to be put back together, then that's also going to be an issue. Then, of course, you've got the obvious political backlash from malfunctions. If a robot malfunctions and hurts someone, then obviously people are going to be averse to using it. Must avoid this at all costs. Okay, so the next aspect of beneficial robots, mitigation of risk. Now this is a very important one because you're potentially now putting a human being at risk, but you can now replace the human with a robot. And if the robot's destroyed, it's much less tragic. So, how does using robots avert risk? Well, obvious one, removing a human being from a hazardous place. This is most useful in industry where if accidents can happen, you can keep humans clear from any of the potential places where they could come to harm. And to most important ones here: remote handling and remote processing of toxic materials. People don't particularly want to carry around radioactive waste, so getting a robot to do it for you, much more beneficial. But how can robots generate risk? Well, if the robot can't be removed from the hazardous location, you're going to have to put maintenance staff into that hazardous place in order to get the robot working again. Obviously something to be avoided. And the second one is the retrieval of a malfunctioning robot in said hazardous place. If the robot's still working and behaving unpredictably, that just adds to risk in an already risk-fueled environment. Again, not beneficial. And now we move on to an aspect that I think is going to be of most interest to the viewers today: the ability of the robot to bring you comfort and leisure. So what can the robot do for you here? Well, it can potentially aid you in your leisure activities. Now, this is of most interest to sportsmen out there. Most of you will probably have encountered ball throwing machines at some point. So if you're a baseball player or a cricket player, it will pitch a ball at you at a specific speed and in a specific way. This aids you in your ability to counter particular pitches and enhance your skills. But for the average person out there, it's most benefit in the creation of relaxation time. Now, this overlaps with the time-saving aspect that I mentioned earlier, but whereas in that area we were talking about saving time for you to do something else, in this particular case, it's the robot doing a job so you can do whatever you want to do to relax. But where can this go wrong? Well, if the robot is constantly being need to be maintained. Now, if you've been paying attention, this is an aspect that has come up in pretty much every single one of these bad columns. If the robot is constantly breaking down, running into things, or otherwise behaving in a manner that the owner doesn't want it to, then it's going to just be tossed. You must sell a robust robot. If you don't, then your company's going to fold very quickly. But in this particular instance, there's an aspect to this that is specific to this question: the inability to properly set up. Now, if we go back to the ball throwing example earlier, if you can't set up the ball throwing robot to throw the ball in the way that you want, then it's of no benefit at all. Ergo, you must liaise with the consumer in this case and make sure that the robot can do exactly what the consumer wants. Now, an often underappreciated aspect of this: the ability for it to educate its user. Now, in this particular case, this will be a robot that goes into a school in order to teach a student how to actually use/build robots. So, how can this benefit our student? Well, it can often elevate a monotonous activity. I don't know about you, but I've sat in design and technology classes where I've rigged up a sensor to a microprocessor, and the only thing that I've had to do afterwards is wave it around and watch the display change. It's not particularly interesting. Would have been much more fun if we'd been able to attach said sensor to a robot and watch the robot wander around utilizing the sensor to navigate. Now, the robot must be easy to understand, otherwise the student's going to feel completely out of their depth. Fairly simple, often not actually applied. But if it's done properly, it's often a prestige project for the school. It gets put in the school newspaper, put in local media, it looks good. And this can be of great benefit to you as a company because it's free publicity. Now, how can this go wrong? Well, as I touched on, if the robot is overly fragile or complex, if it breaks, needs to be fixed constantly, the teachers aren't going to appreciate it and the school won't appreciate it. Or if the robot is overly complex, then the students may feel like they're suffering a 90-degree learning curve. they just won't engage with the robot, and that means you're failing before you even start. And of course, slightly more aspect, if the students don't engage with the lesson plans, so if the robot is there and working, but you don't actually do anything with it, or what you're doing with it is boring, then the students aren't going to be engaged, they're not going to continue in the discipline. And it's important that we encourage more people into this discipline, because we've got a lot of autonomous systems out there, and like 99.9% of humanity doesn't actually understand how they work, and that needs to be changed quite rapidly. Now, let's apply everything that we've discussed before to an actual real-world example. Here's our robot vacuum from our previous video. Designed as a time-saving measure, cheap and cheerful, limited functionality. You all know them, you've all seen them in operation. But how can we improve them? Well, like before, we improve the pathfinding to avoid furniture, make sure it doesn't damage anything valuable, add an arm with a nozzle to reach difficult places so it can get under and around furniture, and we add danger recognition to ensure it doesn't suck up anything that will damage it. Now, from the previous video where we explored this, we realised that the alterations to this design required our target audience to now be middle class and above in order to be able to afford the robot. Now, the money must be made from the sales to outweigh the development costs, and the development costs will be high, especially for the ability of the robot to navigate. And of course, we need to ensure that the robot will actually be accepted by its intended audience. So, given all of this, let's explore a question of how we can make sure that the robot benefits the audience and therefore will be bought. So, background information all given, how does our newfangled robot Hoover justify its existence over the previous iteration? Well, let's have a look at all of the ways a robot can save time. Of them all, the first two are the most likely. So, the robot and the owner will either be doing separate jobs, or they'll be hoovering together to get the job done faster. So, how does our newfangled robot Hoover exceed? Well, in this particular case, because of its ability to navigate and avoid danger, the robot can actually just be left alone to do the job, while the owner does something else. Other robot hoovers that just bounce around need to be supervised in order to make sure they don't suck up anything that the owner doesn't want it to. And the robot can now hoover places where its predecessor cannot. It's not just its ability to fit its robot arm into small cracks in between furniture in order to hoover down there, but its ability to navigate and avoid danger allows it to hoover rooms with delicate objects where its predecessor can't. But where does our project fail in comparison to its previous? Well, let's have a look at the time sinks. What is our robot going to fall victim to? Well, because it can now map its environment, the robot is now going to require a setup to make sure that terrain mapping functionality works, otherwise it's going to be more of a hindrance than a help. But, on the other side of this equation, its ability to avoid danger will lessen any unneeded maintenance time. And of course, zero damage to the environment equals a happy owner. Always a benefit, because that positive PR that the owner will give on the internet will drive sales of your new robot. Now let's talk about the elephant in the room, which is the first time setup problem. Now, any sort of terrain mapping feature or any other complex feature like this will require some form of first time setup for it to work properly, and it may even require some sort of ancillary hardware on site. For example, you can put safety beacons on the furniture in order to make sure that the robot does not run into it. Now, this is a problem, because the owner doesn't want to have to spend the hours and hours necessary in order to both put the beacons on the furniture or set up the software in order to make sure that the robot is navigating properly. You can alleviate this by providing trained technicians specifically for this first time setup. It's not a bad idea, because not only does it avoid having the owner do this potentially badly, but also it's the face of your company, and a good customer technician relation will benefit you later, especially if the robot malfunctions and needs to be checked. But aside from really providing technicians, there's not a lot you can do to mitigate this. As I said, any sort of complex operation is going to require a setup. You can't really avoid it, only mitigate it as much as possible. But it will be a hurdle, especially for a first-time user of the robot whose first experience of the robot will be this massive setup. So, where do we go from here? Well, having determined what our audience is and how they can benefit from this robot, what they need from it, it's time finally to go into hardware mode. But you're not going to be building the entire robot just yet. You're still going to need to test the components that you want to use for their utility in the design and any potential characteristics, especially bad characteristics. But we'll continue this in another video. I hope you enjoyed the video, and as always, have a great day.